Welcome all of you to this video of structure of the atom. Now this is a video in chemistry. This is from chapter 4 NCERT Science 9th Standard CBSE. Okay, so we shall be starting with electronic configuration today and we'll see what exactly is electronic configuration. Okay, let's start. Now before I start the video, I would like to tell once again to you all that if you have not subscribed the video, please subscribe now because lots of more very important questions, very important videos are going to come up in this channel. So if you have not subscribed, please subscribe very soon. Here we are going to do electronic configuration. Now electronic configuration is nothing but the arrangement of electrons around every element. Now every element, be it iron, be it sodium, be it chlorine, each one has a different arrangement of electrons around it. Okay, it all depends on how many electrons it has. Okay, how many electrons does this particular atom have? According to it, the distribution of electrons will happen in the orbits. Okay, so now around every atom, if this is the atom, whatever atom it is of, the electrons go like this. Remember, they don't just go like this, they also go like this, and they also go like this, and they also go like this. You must have seen this picture. Now this distance forms one orbit. Okay, this distance forms one orbit. Now there can be another one which goes like this, another, yeah, you see the distance. Now this distance, the second distance, this is the second orbit. Like this, different orbits are formed. Orbits are nothing but imaginary paths. Okay, so electrons go around the nucleus at different distances from the nucleus, just like it is more or less like how our earth is going around the sun at a particular distance. Okay, same thing. Now, for electronic configuration, they follow this formula 2n squared. What is this standing for? For any orbit, the number of electrons in any orbit follows this formula 2n squared. What is n? N is the number of the orbit. Okay, like if it is the first orbit, we'll put 1 here. So let us take sodium. Sodium has 11 electrons. Okay, we can say sodium's atomic number is 11. That means that it has 11 protons, and that also means it has 11 electrons. Okay, so sodium has 11, number of protons is equal to number of electrons, right? So it has 11 electrons. How will we put it in the different, how will we distribute it in the different orbits? Following this formula, orbit number 1, in the first orbit, 2 1 square, 2 into 1 square, which is a 2. In the second orbit, 2 into 2 square, which is an 8. In the third orbit, 2 into 3 square, which is, okay. So the third orbit has an 18. Now I want to tell here, it is not necessary that the third orbit will have 18. These numbers are the maximum number of electrons an orbit can have. Okay, these are the maximum number of electrons an orbit can have. Okay, so the first orbit can have 2, the second orbit max 2, second orbit can have a maximum of 8, the third orbit can have a maximum of 18 electrons. Okay, now we'll see what it actually has. The first orbit, now since there are only 11 electrons, the first one will have 2, second will have 8, now 10, and total number of electrons are 11. So the third one will have 1, even if the maximum capacity is 18. Okay. Let us now check for chlorine, the electronic configuration of chlorine. Okay, chlorine has 17 electrons. Okay, so if it has 17 electrons, first orbit, that is 2 into 1 square, which is 2. Second, 2 into 2 square, which is an 8. Third orbit is 2 into 3 square, which is an 18. Sorry, 2 into 3 square, which is an 18. But then let's see how much the third orbit actually gets. First, and we can actually write it like this. Okay, 2. Second is 8. The third can get, so that makes 10. Third gets a 7. Okay, so this is the max the third can get. It cannot get more than that. Now we will draw the electron dot structure for, so this is the atom. Now the first orbit will have 2, the second orbit will have 8, okay, 1, 2, 3, 4, write them in pairs, 5, 6 and 7, 8, okay, and the third orbit will have only, the third orbit will have 7 of them, 1, 2, 3, 4, 5 and 6 and 7, okay. So that is the electron dot structure of chlorine. So that makes it 17. Now if we want to draw for sodium, we can draw that also. Let's draw for sodium. This is, if I write sodium here. 1, 2, then 1, 2, 3, 4, 5, 6, 7 and 8. Okay. And then the third orbit has only 1, okay, because that makes it 10 and 11. The third orbit has only 1. So this is the electron dot structure for sodium. Now to give you a better idea, let me quickly draw here I am writing the atomic number for nitrogen. For oxygen the atomic number is an 8. For carbon the atomic number is a 6. For magnesium it is 12, okay. For argon it is an 18. Let's see. Now let's see the atomic numbers of these, the electronic configurations of this. So here 2, first orbit is always 2 maximum, second orbit only 5 left. So what can I do? So here nitrogen, first orbit 1, 2, second orbit 1, 2, 3 and 4 and 5, okay, or you can also draw it like this, okay. So 1, 2, 3, 4, 5, okay. So that makes it nitrogen. Oxygen, here 2 and 6, right. So here I have oxygen nucleus and 1, 2 and this is 3, 4, 5 and 6, okay, and 7 and 8. You can write like this. So this is oxygen has a 6 in the outer orbit, 1, 2, 3, 4, 5, 6. Okay, let's take carbon. Carbon has 6 in the outer orbit. First orbit 2. Second orbit is 4, 1, 2, 3 and 4. Magnesium. Magnesium has 2 first orbit and second orbit is, so this is for carbon it is 2, 4. Here it is 2, 8, 10, 2. Okay, so how to draw this? 2 is drawn 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 8. Now I need one more shell because I have to put 2 more. So here it goes. And you can put 1, 2, okay. So I have put 2 more here, 2 first orbit, second orbit 8, third orbit again 2, okay. Let me now draw argon, okay. So argon, how will I draw argon? Let's see. Argon has 18, so how to draw argon? Now here first orbit 2, second orbit 8, third orbit has to be 8. Okay, argon is little special. I'll tell you why. Here, argon, first orbit 2, second orbit and third orbit again 8. Okay, that makes it 18. Okay. Now here I want to tell you that every element wants to achieve 8 in the last orbit, just like argon has done, though it is not possible. You can see that somewhere carbon has a 4 in the outermost orbit, magnesium has a 2, oxygen had a 6, okay, like this. They could not get the last orbit as 8, okay. When they have 8 in the last orbit, they say it is the octet rule. Now octet rule gets, if you have 8 in the last orbit like this, like argon, it becomes very stable. The atom is very stable. Okay, but then another level of stability they can attain when the last orbit is attained by last orbit gets only 2 electrons. Okay, and that is called the duplet. Okay, so duplet. Now helium and hydrogen, they have very few electrons. This has only one, this has two, and they have last orbit. Okay, so helium has 2 in the outermost orbit. Hydrogen tries to get 1 electron and complete the duplet. Okay, so this naturally has 2 in the outermost orbit. So the ones which have fulfilled the octet rule are called as noble gases or inert gases. Okay, noble gases or inert gases. They are argon, neon, krypton, xenon, radon, okay, and helium. So these are the ones which have complete, in all these inert gases, helium has completed duplet. Otherwise, all the other inert gases have completed the octet rule. Now last, I repeat, whatever is the number of electrons, if it has 8 electrons in the outermost orbit, that means it has attained stability. It can become very stable with last orbit having 8 electrons. Other atoms are not that stable. So whoever, here it has 2 and 4 in the outermost orbit. So carbon is always looking for another 4. Okay, carbon is always looking for another 4 to complete its octet. Magnesium is trying to give out those 2 and attain the last orbit to attain octet. Then if it gives out 2, then last orbit will be 2 for magnesium. So magnesium is wanting to give out that 2. Okay, before this we saw in sodium. Sodium had last orbit, this is 2, 8 and 1. So sodium wants to give this out so that it can attain octet. Okay, whereas 2, 8, 7 for chlorine. Chlorine wants to take 1 to complete its octet. Okay, so those who have less than, those who have 1, 2 or 3 electrons in the outermost orbit, they will try to give and attain octet. Those who have 5, 6, 7 electrons in the outermost orbit, they will try to take few electrons and attain octet. Okay, to obtain stability. So that is where we have something called valency. Okay, what is valency? You must have heard of it, valency. Now valency is, sometimes it is said, the combining capacity. Okay, combining capacity of an atom or an element. Okay, that is called valency of that element. So valency of sodium is 1. Why? Because it will give this 1 to somebody and attain stability. So we can also say it is combining by donating 1 electron. Okay, chlorine on the other hand takes 1. So chlorine also has valency as 1, but it has -1 valency. Here it has +1. If you are giving, it's a +1. If you are taking, it's a -1. Okay, so the combining capacity of an atom is called its valency. If you talk about magnesium, magnesium has a valency of +2. Why? Because it wants to give this and come to its stable configuration. Here this one has a valency of 4 because it wants to take 4, okay, or it wants to share with 4, like that. Oxygen has 2 and 6, so it wants to take 2, so it has a combining capacity of a valency of -2. So all those who are taking is negative, all those who are giving is positive. So like that it happens. Okay, so let us quickly draw the electronic configuration of few more of the elements. Aluminium, atomic number 13. Phosphorus, atomic number 15. So here let's talk about the electronic configuration. First is aluminium has atomic number 13, 2, 8, 10 done. Now 3. 2, 8, 3, that makes it 13. 2, 8, 10 and 5. Okay, here 2, 8, 10 and 4, that makes it 14. Okay, so these are the few more of the electronic configurations. So all you have to use is this. You have to keep using this so that you understand what is the maximum capacity of electrons in one orbit. Okay, this number should not exceed that. The maximum capacity here is 18, so 5 is okay, like that. Okay. Now we are going to take up 4 more things. One is atomic number. One is mass number. Then comes isotopes, and then comes isobars. Okay, so we are going to learn about each one of them now. Atomic number. Atomic number is number of protons, okay, in the atom of an element. Number of protons. Okay, so number of protons, if it remember, atomic number is actually, the definition is number of protons, but actually it applies for number of electrons also, because number of protons is always equal to the number of electrons. Mass number is the sum of the number of protons, the sum of the number of protons and neutrons in the nucleus. In the nucleus, that is the mass number. Now atomic number, let's say for sodium is a 11, for chlorine is a 17, like that. Okay, for magnesium it is a 12, like that. Okay, mass number. How do we understand the mass number? If the other numbers are given, if the atomic number is given, we'll do small questions on this later on. Isotopes. Now isotopes are different atoms. Now what happens is, sometimes supposing I have this many chlorine atoms, okay, then, or some carbon atoms. Few of the chlorine atoms have a different mass number, and let's say out of these a certain number has a different mass number and another number has a different mass number. Okay, so all of them don't have the same mass number. If they don't have the same mass number but they have the same atomic number. Okay, if they don't have the same mass number but they have the same atomic number, in that case atomic number is same means number of protons is same. Okay, so and electrons is also same. What is differing? Why is the mass number differing? Because protons plus neutrons is mass number. So that means the neutron must be differing. Okay, so supposing I have chlorine here, few of the chlorines will have one kind of mass number, another few will have another kind. Now remember, whenever this happens, these two chlorine atoms are called isotopes of one another. And what happens is, these isotopes are always found in a particular ratio. Okay, so if I am talking about chlorine isotopes, they will be found in a particular ratio. So, but then in a mixture form. But they never tell us, to take them out separately. Why? Because the chemical reaction of all isotopes is the same. So we are not bothered about, in a chemical reaction, as long as the reaction is same, we are not bothered about which isotope it is. Okay, so basically it is a difference in the neutrons. Okay, now these are atoms of different elements. Remember, isotopes come from same element. Okay, only carbon or only it can come from only carbon or only chlorine, anything. You'll find isotopes in uranium. Okay, uranium has isotopes. If you want to give few examples, cobalt has isotopes, carbon has isotopes, chlorine has isotopes. Okay, then there can be many more things which have isotopes. Now coming to isobars, they have same mass number, different atomic number, and they come from different elements. This is to be remembered, different elements. Okay, they don't belong to the same elements like you had for isotopes. Okay, now they come from different elements. Like cobalt, atomic number is 18. Okay, Calcium atomic number is 20. But both of them have a mass number. Okay, they have a mass number. Calcium and cobalt both have a mass number of 40. Okay, so that is how they differ. Now, one very common question is that comes in your exam: why do isotopes have the same chemical properties? Okay, chemical properties. Why do isotopes have the same chemical properties and different physical properties? Physical properties. Now, this is one question that is very commonly asked in every exam. Isotopes, what I just now said is they have the same atomic number. Now, what depends on atomic number? Okay, what depends on atomic number? The electronic configuration will depend on the atomic number, right? The electronic configuration depends on the atomic number. Now, if the electronic configuration is depending on the atomic number, so supposing 281, then the electronic configuration will tell us last orbit has 1. Okay, if the last orbit has 1, its valency will be 1. If the last orbit is having 5, valency will be 3. So like that. Now, chemical properties of any element depends on its electronic configuration, which gives us the valency. Okay, so this one actually decides how the element is going to react, and this depends on the atomic number, the number of electrons. Okay, therefore, as long as the atomic number is same, which is so in the case of isotopes, their chemical properties are same. Okay, but then physical properties are different, because physical properties of any element, physical properties depend on the mass number. Okay, therefore physical properties depend on their mass number. Mass number is different, therefore their boiling point, okay, their melting point, these things differ because they have a different physical property, they have a different mass number, so they have a different physical property. So chemical properties depend on atomic number, physical properties depend on mass number. Okay, so if you remember this, you can answer all the questions that are based on this. Few uses of isotopes. Now, few uses of isotopes. Generally, now if chlorine has 2 isotopes or cobalt has 2 isotopes, it is not necessary that both of them will be useful in the same way. So, one particular cobalt isotope is useful for treating cancer. One particular uranium isotope is used in nuclear reactor as a fuel. One particular iodine isotope, okay, this is used for the treatment of goiter. So as I said, every isotope will not be useful. Okay, so carbon also, we use one for radiocarbon dating, like that. So different isotopes find different uses. If we are given the atomic number of anything, as a 9, number of neutrons is given as a 10. Okay, now we have to find the number of electrons. The number of electrons is same as the number of protons, which is equal to the atomic number, therefore 9. Number of protons, if they ask, that is also 9. Okay, atomic number is given. Atomic mass, now that's one thing they might ask us, or mass number. Atomic mass or mass number is the same thing. So atomic mass is neutrons plus protons, isn't it? So neutrons plus protons, that is 19. So this is how you can find different values. Atomic number is 16, mass number is a 32. Protons, then how much? Okay, they give you only this much, they ask for the protons. Protons is a 16. Electrons, how much? Electrons is a 16. Okay, then neutrons, how much? Neutrons is a, neutrons is protons from mass number. If we subtract the protons, okay, from mass number, if you subtract the number of protons, 32 minus 16, that is 16. Now it is not necessary that number of protons and the number of neutrons will be always equal, not at all necessary. Look here, protons, okay, neutrons, they are differing, so it is not necessary. Here in this case they are equal, they can be equal, they cannot be equal. So that was it from this chapter of structure of atoms. This part is a very scoring chapter, very scoring part of this chapter. You know few definitions and you can do all the questions in this part. Okay, electronic configuration is very easy once you understand it. Okay, the first part of the chapter is done in structure of atoms part 1. Okay, and this one is structure of atoms, it comes under part 2. Okay, so you can go through the playlist, you will get all the videos. If you have not subscribed, do not forget to subscribe. Thanks all of you. Bye then.